The internet feels pretty much instant, doesn't it? But here's a wild thought. The very foundation of our entire global network, that humble little optical fiber, is actually hitting a wall, a fundamental physical limit. But what's really incredible is that there's a revolutionary new technology based on a surprisingly simple idea that's about to completely shatter that limit. Let's dig into how it all works.
Okay, so first things first, we've got to understand the core problem. See, there's this hidden bottleneck in our global communications network that most of us don't even know exists. And the crazy part? It's built right into the very fabric of the internet itself. So that brings up a really fair question, right? We're sending data using light, so shouldn't it be traveling at, well, light speed? You'd think so. But the answer, it turns out, is all about the stuff that light has to travel through.
So, check this out. Light is only at its absolute fastest when it's in a vacuum, empty space. The second it hits a denser medium, like the glass in a fiber optic cable, it slows way, way down. We're talking over 31% slower. That means every single bit of data we send, every email, every video, is constantly tapping the brakes.
And this isn't some small niche problem. We're talking about 550 million kilometers of cable wrapped around the globe. That's enough to go around the Earth thousands and thousands of times. So this physical limitation, this glass ceiling, is literally embedded in our entire global internet. It's a very real speed limit on our data. So, how in the world do you fix a problem that's literally woven into the planet's infrastructure? Well, the answer is an idea that is both totally radical and at the same time just beautifully simple.
And here it is, hollow core fiber. The concept it's brilliant. If sending light through a solid piece of glass is what's slowing everything down, then why not send it through air? But keep it inside a fiber. This lets the light travel in what's pretty much a vacuum, getting us incredibly close to the true universal speed of light. It's just genius.
Yeah, and this quote from a recent research paper just nails it perfectly. The entire point of developing hollow core fiber is to get around those exact physical limits of glass we've been talking about. This is a technology purpose-built to smash right through that glass ceiling.
Okay, but wait. How do you actually trap light inside a hollow tube? I mean, you can't just use a glass straw, right? The light would leak out everywhere. It actually takes some seriously clever physics and engineering. And it turns out there are two main ways to do it. All right, the first method, which is kind of the older tech, is like building a photonic cage. It uses this really complex honeycomb of glass that basically creates a crystal structure that just forbids light from escaping out the sides. It's cool. But the newer method, the one that's a real game changer, is like a hall of perfect mirrors. It uses a ring of these impossibly thin glass tubes that perfectly reflect the light over and over, keeping it bouncing right down the hollow center. Now, let's connect those ideas to the real tech. That perfect mirrors approach, its official name is Nested Anti-Resonant Nodeless Fiber. Yeah, it's a mouthful, so we'll call it NAMF. And NAMF is just better in pretty much every single way. It gives you way more bandwidth, the signal loss is extremely low, and it's a lot less complicated to make. So yeah, NAMF is definitely the future of this technology.
Okay, so we've figured out how to trap light in air. Awesome. But what does that actually get us in the real world? Well, this is where it gets really, really exciting. This breakthrough basically gives our data a whole new set of superpowers.
First up, and this is the big one, raw speed, or more specifically, lower latency. By just letting light travel through air instead of glass, we slash the travel time, the latency, by over 31%. That means the data is traveling almost 1.5 times faster than in the best conventional fibers we have today. Now, to put that into perspective, let's say you're sending data over 1,000 kilometers. Hollow core fiber saves you 1.6 milliseconds. I know, that doesn't sound like a lot, but in worlds like high-frequency trading or trying to sync up thousands of 5G towers, a millisecond is an absolute eternity. Okay, superpower number 2 is signal purity. Because the light is barely touching any glass, the signal distorts 10,000 times less. Now, that technical term, nonlinearity, basically just means the signal gets all messy and corrupted as it travels. By avoiding that mess, we can cram way more data into the signal and send it much, much farther without needing to boost it. So, let's just recap real quick. The 3 big superpowers of hollow core fiber are 1. Near light speed latency, 2. immense bandwidth to carry way more data, and 3, virtually zero distortion, which means a cleaner, stronger signal that can go the distance. This all sounds incredible, right? Almost too good to be true. And, well, we're not quite ready to replace the whole internet with it just yet. So let's take a balanced, realistic look at the hurdles that are still standing between the lab and a world running on a hollow-core internet. Right now, there are 3 main challenges engineers are wrestling with. First, just connecting these fibers together, splicing them, is super delicate. The hollow part can actually collapse from the heat. Second, they can get contaminated. If dust or moisture gets in, it can really mess up the signal. And finally, making the stuff is still pretty complex and expensive. These are the big problems that need to be solved.
So where are we going to see this tech first? Well, the first big real-world application is already happening in high-speed trading. We're talking about an industry where a few microseconds, millions of a second, can be the difference between making millions of dollars or losing them. For those supercritical data links, HCF is already being installed.
Next up on the list, data centers. You wouldn't believe the amount of cabling inside one of those massive buildings. All that wire creates its own internal lag that can slow things down. But just swapping that internal cabling for hollow core fiber could boost a data center's total performance by up to 8%. And that's without buying a single new server. That's a huge efficiency gain. And looking a little further down the road, hollow core fiber is going to be absolutely essential for 5G and especially future 6G networks. See, these technologies depend on perfectly synchronizing thousands and thousands of antennas, and the super low, super stable latency of HCF is pretty much the only way to get that kind of precision at a massive scale. So, as our world's hunger for data just keeps growing and our demand for instant connections becomes more and more critical, the physical limits of glass are becoming a real problem. It leaves us with this really fascinating question. To build the next generation of the internet, do we need to abandon the very material that made it possible in the first place? Could the future of the internet really be hollow?